Imagine a world where computational efficiency and high performance in language modeling coexist. Welcome to the world of RetNet. As we venture into this exciting realm of artificial intelligence, let's take a moment to compare RetNet and transformers. Developed by the tech giant Microsoft, RetNet is a novel architecture designed to overcome the limitations of both recurrent neural networks and transformers. Picture this. Transformers, in their quest for training parallelism, use a self-attention mechanism. Sure, it sounds impressive, but here's the kicker. It suffers from high memory complexity and inference costs. That's like trying to run a marathon with a backpack full of rocks. Now, enter RetNet. It takes the stage with a promise to bring the best of both worlds, the parallel training capability of transformers, minus the heavy backpack. It's like running the marathon, but this time with a featherweight vest. As we see, RetNet seems to be the answer to the impossible triangle faced by sequence models. But let's dive in deeper. Scene script. RetNet might sound complex, but let's simplify it. Imagine you're at a party and you're trying to listen to multiple conversations at once. It's hard, right? Transformers, a type of artificial intelligence, face a similar challenge. They use a mechanism called self-attention, which allows them to listen to all parts of a sentence at once. But just like you at that party, they struggle. They have to maintain large matrices, which is like trying to remember every single conversation word for word. It's memory intensive and slow. Now, enter RetNet. It introduces a new mechanism, a multi-scale retention mechanism. It's like having a superpower that allows you to remember only the important bits of each conversation, making it easier to process and recall information. This new mechanism replaces the self-attention mechanism used in transformers, reducing memory consumption and improving speed. RetNet also utilizes 3 computation paradigms. Think of these paradigms as 3 different strategies or approaches to solving a problem. The first is parallel representation, which is like training a team to work together efficiently. The second is recurrent representation, which makes inference or prediction more efficient. It's like if you could predict the topic of the next conversation based on the current one. And the third is chunkwise recurrent representation, which is great for long sequence modeling. This is like breaking down a long, complex conversation into smaller, manageable chunks. In essence, RetNet is a blend of the best parts of RNNs and transformers, all while making it more efficient and memory-friendly. Why should we care about RetNet? Well, it has some distinct advantages. Developed by Microsoft, RetNet is a new architecture that merges the best of both worlds, the parallel training capability of transformers and the memory and computation efficiency of recurrent neural networks. It tackles the impossible triangle of training parallelism, low-cost inference, and robust performance, a challenge that has been a tough nut to crack for current sequence models. One of the key features of RetNet is its multi-scale retention mechanism. This innovative approach replaces the self-attention mechanism used in transformers, reducing memory consumption while improving throughput and latency. It's a bit like having your cake and eating it too. RetNet also cleverly integrates 3 computation paradigms. It uses parallel representation for training parallelism, recurrent representation for efficient inference, and chunkwise recurrent representation for long sequence modeling. This flexibility allows it to handle a variety of tasks with ease. Now here's where it gets even more interesting. During training, RetNet switches out the softmax operation, typically used in transformers, with a Hadamard product and group norm operation. This change eliminates the need to store large matrices, resulting in faster, more memory-efficient inference. It's like switching from a gas guzzler to a sleek electric sports car, faster and more efficient. Moreover, RetNet doesn't just match the performance of previous attempts to approximate softmax, it surpasses them while maintaining a performance comparable to transformers. That's like running a marathon at a sprinter's pace. With RetNet, we're looking at a future of improved language modeling performance with lower memory consumption, higher throughput, and lower latency. Truly a game changer in the realm of AI.